So in the last video, we looked at a robot which was programmed in C++. This is a pretty naive robot. It can drive around the room on its own, but it's not that smart. It drives into walls on occasion. That's down to the limitations of time. Now, C++ is what we call an object-oriented language. An object-oriented language is one which allows us to model the real world in a way that we can measurably use this data in a computer, reason about it. And fundamentally, it's a lot easier to program in as well. Brian Koningham, Dennis Ritchie and Ken Thompson, they worked on C when they were at Bell Labs. And this was revolutionary at the time because there were loads of languages, but C was one of the more accessible ones. There was a fellow down the hallway called Bjarne Stroustrup. Apologise if I got that wrong. He thought he could extend this idea by adding what we call classes. Now, classes allow us to model complex data, often from the real world, using code which often seems more intelligent and it seems more sensible. Say you've got a pet shop and you want to keep track of all your dogs, your cats, your parrots. In C, you could do this by maintaining a list of names, say Fido, Spot, Donald, I don't know. And you might have a corresponding list of ages of these animals as well. Now that's useful, but it can quite easily get out of sync. You might remove one dog from the list, but forget to remove its age. And then you've got a mess because you've got your incorrect data, and that's probably one of the worst things that can happen. So this is where object-oriented programming comes in that you can essentially look at the real world and go, so I've got this entity which we call a dog, so it's probably going to have a name, say, I don't know, Fido. It's going to have an age, might be 2 years old. It's probably going to have a weight. It's quite a big dog, so it's going to be 45, St. Bernard or something. Might have a height too. Now, in C, this might be represented as multiple lists of things. So you might have a list of names for all your dogs, and then corresponding list of ages for all those dogs, weight and height, so on. In object-oriented programming, you can essentially combine this into one singular record, which you can then use to keep the data together. More formally though, an object is an instance of a class.
So the class is a bit like a template?
Yeah.
And then an object is a template that's been filled in?
Yeah. So it's like, say you've got a template for a CV. It's like you're going to have a name, you're going to have an address, a date, age. Everyone's going to have this template, but you fill in your specific details. It's the same with object-oriented programming. The class is the template in which you make your dogs, and then the objects are the specific instances for each dog. So, you know, Fido, Spot, so on. So it's literally templates. Classes don't just contain objects and data; they also contain behavior as well. Now, the behavior we'll go into a bit later. But it's essentially the other half of the cake, and it's also very important. Before object-oriented programming, you had simple list of numbers. Now, with object-oriented programming, it's a bit more complex because you can have a list of dogs, each of one which will have its own name, its own age, and so on. And that makes it a lot easier to write programs. A lot of the time, data looks really hard. It's hard to manage, it's hard to deal with. So object-oriented programming, in a way, is simplifying this process so that you can write programs easier and get more done in less time. And that's probably the best thing about it, really.
Are there lots of examples of object-oriented programming languages?
Yeah, there's loads, yeah. So C++ is the most popular one, and Java is another popular one that's used these days. I'd say C++ is used more for hardware stuff because it's much more close to the metal, whereas Java takes away a lot of the details so you can focus on getting more stuff done. There are other languages such as JavaScript, which is in a way object-oriented. This is a topic of debate on the internet. Some say it's object-oriented, some say it's object-based. They're two different things, but essentially JavaScript also has objects and classes. So in a way you could argue it's object-oriented.
I know I've made enough computer files to know that people can be very tribal over languages and things like that. So what are the drawbacks? Is it slower? Is it?
A lot of the compilers these days and the programs which make your code work, they've optimized it down so it's quicker, but the biggest problem with object-oriented programming is an idea called abstraction. And abstraction is where you essentially only show the data that you need to show when you need to show it. Now this is good because this allows you to hide away data which will confuse you. Say you're trying to maintain a pet shop. In classical languages you might have a list of dogs, list of names. You've got lots of complex data there. Now equally, if you combine it into a single list of dogs, that's simple. But to anyone who comes along to look at your dog database, they may not necessarily see that you've got dog objects with all this complex data. So the main drawback is hidden complexities, abstraction. The detail's hidden away from you so that you don't have to worry about it at that point. You can get on with working with it. But at the same time, it does take a little while to get over the initial hurdle so that you can work with it. But once you're there, it's a lot quicker, it's a lot easier.
Great book. You should buy the newer version of this. Sorry. Brief commercial announcement.
Are there some problems that are so awful that no algorithm can exist?